And right now I am in chapter number 12, page number 571. So when we say exception handling, as I told you guys that in exception handling, we're pretty much talking about how you can handle the problems internally within the code without having to pass on it over to the system to handle it for you, which gets a little bit nasty because the system takes the control from you and then you cannot come back to your program and do the rest of the job. That's why we do it inside the program. Exception handling is basically error handling. Now comes the question, then why in the world do we not call it error handling? We used to call it error handling, but not anymore, because now we differentiate between errors and exceptions. Exceptions are those kind of errors where recovery from where the recovery is not possible. And exceptions are those kind of errors from where the recovery is possible. So that's why error and exception are two separate concepts in Java. An exception is an unexpected or error condition. However, a program might issue some kind of a warning to the code saying, here you go, handle it. If nobody can locally handle it, then system handles it in the end. It is also possible for you to write your code in such a way that, let's say you have a function. That function called another function. The caller and the called. We have two functions running in the stack right now, but called is at the top, caller is at the bottom. The called made an error. And if called, after making an error, does not have a local try-catch block, the error will be handed over to the caller. If caller doesn't have the try-catch block, it will go to its caller. And the process will continue until you reach main. If main doesn't have anything to deal with the error, then it will be given out over to the system to handle it. So it is possible for you to have a called caller relationship in such a way that the called statement is in a try-catch block, that if called method makes any mistake, the caller can handle the error message. You can also do that. It is also possible for you to forcefully raise an exception, that if this condition occurs, I want to raise an exception. I want to call the catch. It is also possible for you to write your own exceptions as children to the built-in exceptions. So all of these things are possible. So errors or exceptions is what we'll be looking into. This is just a snapshot of some of the exceptions inside Java. Object is the parent to all exceptions. Now, object has a child called throwable. Throwable is actually an interface, it's not a class. It's part of the java.lang package. Now, throwable interface has a child called exception. The exception is the parent to all kinds of exceptions, okay? And is also parent to error, which is a branch out of the exception. Okay, now exceptions can be categorized as input-output exceptions that you will mostly see in chapter 13 because we'll be doing read-write. There could be runtime exceptions. There could be arithmetic exceptions. If you are trying to access an index of an array which doesn't exist, so array index out of bounds exception. If it is not an array, okay, then you can have index out of bound exception. Or you're trying to reach something that doesn't exist, so no such element exception. You're trying to put a data from one type to another, but it's a type mismatch, so input mismatch exception. So similarly, when we are dealing with other kinds of errors, which are hardware related, it could be virtual machine related. So you can also have a virtual machine related error, such as out of memory error, internal error, and there are many other errors and exceptions that can be used from the Java exception handling package. Now, here is an example where we see that the user inputs a number, a very simple example that you can understand just by learning chapters 1 and 2. Everybody understand this example? I want everybody to look at it. Okay, so what are we doing in this example? It's a very simple example in which we are accepting an input from the user, and Christian will explain the rest of the example. Yes, Christian. Yes. Can you explain the example?
Probably not.
So again?
Probably not.
Why not?
I'm not sure what we're doing.
Can you see my screen?
I can.
Yes, explain this example.
Okay.
Yeah. It's based on chapter 2.
Okay. So we have this scanner. So it's looking for something in the variable, the int, numerator, denominator, and result. And then system out, enter the numerator, then user inputs an integer, and then it asks for the denominator, and then user inputs a denominator. The result is the numerator divided by the denominator, and then it prints out the numerator divided by denominator, and then equals result.
Very good. See that I don't know change to answering the question. Okay, nice. So in this example, we simply accept an input from user for numerator, another input for denominator. We divide the two. And what is the chance of having an error? The chance of having an error is that if you divide the numerator by the denominator and the denominator is 0, then you run into an error. And that'll be divide by 0 error. And divide by 0 error will be considered as an arithmetic exception that we looked at in this list here. The arithmetic exception will be raised, and this is the error message that will be generated, divide by 0. And then it also tells you the line number on which the error occurred, which would be, in this case, whatever the line number 12, where the calculation is taking place. To handle this error, or for example, if somebody entered 3, like character 3, then you may run into a type mismatch error, or enters a double value when you were actually expecting an integer value, then you may also see input mismatch exception. All of these exceptions can then be handled one way. The old way of handling exceptions, that is more like a 70s way of handling the exception, is by writing an if condition. That if denominator equals to 0, then say cannot divide by 0 and don't do any calculations. And only do the calculations if the denominator is not 0. And a lot of the people would be like, that works perfectly fine. But this is the procedure-oriented programming approach. If you want to generate any kind of useful information out of the error, you can't, because you have fixated yourself into cannot divide by 0. In this case, it's very simple because you knew ahead of the time the only possibility of error that could occur is when the user enters 0. What if the user entered character values? We can't really handle anything with an if condition. It will definitely go to where? To the system. So try-catch is more sophisticated approach where any and all kinds of errors can be handled by the try-catch block, and you want to avoid going to the system to handle the errors. So to make that happen, on page number 577, this is a typical syntax of a try-catch block. You write a bunch of statements in a try block, then you have a catch block. At the beginning of the catch block, in the parentheses, you mention the exception, which is the most generic kind of exception, or a particular exception type and the object of that exception type. And here is an example. The only thing that you want to put in the try block in this example should be the actual division, because that is the only statement that can cause error in our case. So if numerator gets divided by denominator, if that is an error, that will jump to the catch. And catch is saying, I am only catching arithmetic exceptions. I'm not catching any other kind of exceptions. So if it's an arithmetic exception, I'll say arithmetic exception was thrown and caught. Now comes the question, if there is an error made on when we are accepting denominator from user or numerator from user, will that still go to catch?
No.
No. Only if the error is made in the try block will go to the catch block. If the error is not made in the try block, then it will not go to the catch block. So there isn't a concept like what we learned in control language last week. There isn't a global monitor message. We don't have any such idea here. The global monitor message will handle any kind of errors happening in the program. We don't have anything like that here. Okay, so now looking at this example, example number 12.9, the only thing different we did over here is that instead of hard coding the message, arithmetic exception was thrown and caught, we're now relying on the built-in get message method. Now that you have done chapters 3 and 4, you can easily tell that if an object, because mistake is the name of the object of arithmetic exception type. So if an object call a get message, it has to be a getter. And so we are trying to display a class property. What class property are we trying to display? We're trying to display the error message. And that's a class property that gets displayed get message, and it displays the error message on the screen. So this is the divide by 0 error message. Okay, let's do this. How about you guys do this program, create a new Java project for today, and write this program, figure 12-9, and run it. And once everybody is done, you can give me a green check. In the meanwhile, let me complete the attendance of the people that were not there at the beginning. So Christian is over here now. Christian is with us now. We don't have Mason, right? Right. But we do have William. Okay, cool. So this is page 577 of your ebook.
Are we doing both chapter 12 and 13 today?
Yes.
Okay.
That's the plan.
Okay. Just so I know if I should call my project chapter 12 and 13 or separate them.
That's fine. It's up to you, however you want to do it. except for a couple of few, everybody else seemed to be done. Okay, William is the only one still working on it. Okay. So now let's scroll down to page number 581. Using a try block to make programs foolproof. It is always a good idea to include as many lines as possible in your try block so that, for all possibilities you could handle. One of the things that you can do in this regard is to create a try block with a most generic catch, like you can see in this example. We're using the most generic catch called exception. So here, the for loop goes from 0 through the length of the array. Every time it runs, it grabs a value from the user and puts it in the array. If anything goes wrong with the value, it will call the exception, and the exception will simply raise an exception occurred. And then we are simply displaying the values back to the user. So exception is the most generic kind of an exception, kind of saying that foolproof means that you will be able to catch any and all kinds of exceptions in that regard. Okay. Now, since you are in a loop in this case, as soon as you hit the catch will omit that particular element in the array. But because it's inside the loop will still continue and will grab the next element in line. So as a result, over here, as you can see, that we entered 11, 22, W, exception, exception, exception. So out of the 6 possible choices, only 2 were correct. The rest just went with errors. So as a result, we only had the first 2 values filled out, the rest remain 0. Okay. And here is another example where some of the middle ones were left 0 because of the error, but the rest were filled. Okay. So now create your next class, a new class, and do this example, which is figure 1212 on page 581. Let me clear your feedback so that when you guys are done with this example, you can then give me your new feedback. So Christian, Cole, Robert, 3 people are yet to complete. Okay. Robert and Cole. Any questions from those of you who are done?
So adding in the commented out input next line would essentially just allow you to get an exception and continue on with that same process. Like, because now when you get an exception, it ends it completely and says, you know, exception or whatever for all the remaining parts of the array. But then there's that commented out one.
Oh, yeah. The commented out one is for absorbing an enter key if they were string. So for example, if you turn to figure 1214, see it says this line is commented out for the execution in figure 1213, but not figure 1214. So if you are running for what you see on in figure 1213, you will see that right in the second picture on figure 1213, you will see that you're also entering letters. When you enter letters, the letters act differently than numbers, because an enter key is a valid absorbable key. So an enter key is a valid key for a letter. So that's why, you know, we have used this to absorb the extra enter key so that doesn't becomes an input for the next one. But if you're only entering numbers, then that's perfectly okay.
Got it.
The only difference between your division mistake caught number 2 and division mistake caught number 3, which is on page 586, is that now we put the entire text in the try block, the accepting all the user inputs along with the calculation and even the output, everything is in the try block. And we wrote multiple catches. We have one catch which will catch only the arithmetic exception. Then we have another catch that will only catch the input mismatch exception. So whenever an error is raised, it will go through the list of the catches. Whichever catch is true, it will run that exception. And it will then totally ignore the rest of the other catches. It will totally ignore the rest of the try block. And the control will resume to the end of the program. So that's basically writing a program with multiple catches. That's what this program does. Now, if you do not want to write multiple catches and you only want to write one catch to handle all kinds of problems, then figure 1220 shows you that you can write a catch with only the exception type. So it's the most generic one and will catch any and all kinds of exceptions. And page number 592 talks about the finally block. The finally block's idea is that irrespective of try or catch, if you want some piece of code to run either of the two, it doesn't matter which one of the two runs, then you will run the finally block. For example, if my try block is reading the data from the file, and if anything goes wrong, or if everything is done successfully, if I'm able to complete the whole reading process successfully, in either of the two cases, I want my file to close so I can do that in the finally block. The finally block will run irrespective of try or catch. So that's the only benefit of having a finally block. So open file, read file, place the file data in an array, calculate an average, display, whatever these steps are. If all these steps complete, I'll go to finally. If any of these steps error out, I go to catch and I'll still end up in finally. So that's what the purpose of the finally block is. Understanding the advantages of exception handling. So here is one example in which author is telling us that if you're trying to, hold on, so you basically made a call to method A, and method A, if doesn't have the local try-catch handling, the call will come back to the try block, where you will then look for the respective catch. Whichever catch is associated with the error generated by A will be raised. If A comes back successfully, then B will be called. If B comes back successfully, C will be called. If C comes back successfully, then everything is okay. So it is quite possible the caller can have a try-catch block for the called. Now look at this example. In this example, we are creating a class called price list. It lists a lot of prices, and it has a method called display price. Now, display price does not have any local try-catch block, but display price can run into an error. How display price can run into an error? Because I'm passing an item number, and then on this line, we are going into the price array. There's a mistake in the book, by the way. You know, when you guys code this, fix it. It should be prices. When you go to the prices array, you're looking for that item number that is being passed. If you pass, let's say, index number 6, index number 6 does not exist because there are only 0, 1, 2, 3. Those are the only index choices you got. So as a result, you will run into an index out of bounds exception. So what you are telling at your method level is, if this line fails, I want you to throw an exception call of index out of bound exception type. Who will catch this exception? Whoever calls display price will catch the exception. So let's scroll down. Here is a method. Here is main method, which is accepting an item number from the user. In the try block is making a call to the display price method in the price list class. In case if that line errors out, the control will come back to the try, which will then pass it over to the catch, which will then display the price as 0. So as a result, you know, if there is any error, the price is 0. This is one implementation. Now let's look at the second implementation. The second implementation of the same idea is that instead of saying the price is 0, the catch will actually call display price again, but this time we'll provide a value of max item, which is 3, which is a declared constant in the class, to make sure that if no item matches, I should get the highest available index number price. So instead of just giving 0, it will give the highest price as the output. So here we have the output from the first picture, which is price list application 1, and this is from price list application 2, and you can see the difference between the two outputs. So again, what I would like you to do is first code this one, price list application 1. When you're done with this, you have to start with this. Yeah, create a class called price list first, and then in a separate class, you will create a price list application 1. Test this. You may want to pass a value between 0 and 3 so that you can get a proper price. And then you will try with a value over the 3 so that you can get 0 as an output. Then save your price list application 1 as price list application 2. Make the necessary changes and again, repeat the process. There, does everybody follow?
Yep.
Okay. So work on these 3 programs. And again, notify me in the participation through the green check.
when we're writing the price list class, for prices, it says the line where it has private static final double, it says prices, and then in the system out print line, we do price item. Is it supposed to be prices item?
Yes, as I said, that there's a mistake in the book.
Okay, all right. Got it, thank you.
So only Sparrow and Christian are left. Everybody else is done. Okay, guys, now I am on page number 601, where we'll be looking at the example demo stack trace. In the main method, we are making a call to method number A, method A, and in the method A, we are making a call to method B. In the method B, we are making a call to method C. In the method C, we have an array. 0, 1, 2 are the values inside the array. We're trying to print an index number 3. Index number 3 doesn't exist. Therefore, line number 21 will generate an error. Since there's no try-catch block in method C, it will fall back to method B. Since there is none in the method B, it will fall back to method A. None in the method A will fall back to the main. None in the main, it will then go back to the system. So if anyone to look at the demo stack trace, you will see that 21 generates an error, which affects 15, which affects 10, which finally goes to 5, and then it's handed over to the system. So that's basically how the stack trace works behind the scene. In this particular example, which is a little improvement from the previous one, is that before the control resumes back to main, in the method A, where we are making a call to method B, we have a catch. That if method B comes back either from its own body or the body of the method that it has called, with an exception of array index out of bound, then A will handle it. So if you can see the output over here, The A, the stack trace, that's coming out from the catch of the A, and it basically displays the message. It displays what went wrong, and then what went wrong is coming out because we are printing the stack trace. If we do not print the stack trace, then we won't be able to see what really went bad. Usually in the testing, we print stack trace. And when the testing is done, we comment out those lines. So, and then we will just work with the rest of the code normally. So as you can see, the control resume back to the line which read method A ends normally, and then application could continue from this point. So all of this was a proper program termination, as opposed to in the previous case where the program terminated improperly. Okay. So I would like you to code this example, figure 1235, which is on page 601, demo stack trace 2. So everybody seemed to be done except for Christian and Cole. Did you guys get the desired outputs? Those of you who are done?
Yeah.
Okay.
Yep.
So far, we have looked at how you can create a try-catch block, a program with a single catch with multiple catches, how you can make one method pass on its errors to another method, which is its caller, and that's how you can also handle the problems. There is one more topic that we'll be looking at. That will be the last topic in this chapter that we'll be looking at, and that will be how to create your own exceptions. When you're creating your own exceptions, your class has to be a child of a built-in exception class, for which I'm going to page number 605, creating your own exception classes. So in this one, you will create a class like we're creating high balance exception, which is a child of the built-in class exception. As a result, it will get all the non-private entities from exception. Then what we're doing is we are writing a constructor of the child, and we're making the child call the constructor of the parent. Remember the super that we learned in chapter number 11? That super is a way for you to call the constructor of the parent, in this case, the constructor of the parent, that takes one parameter. And this is how we are setting our error message. That in case anybody raises an exception of high balance exception type, this is the error message that we want to display. Okay, moving down, we want to create a class called customer account. In the customer account class, we have a property called account number. We have a property called balance, and we have a constant called high credit limit. 20,000 is the value. In the constructor of customer account, where we're basically taking two parameters, num and balance. And we are assigning num to account num and bal to balance, and we are checking the value of balance. If balance exceeds 20,000, which is the value of high credit limit, then we want to throw an exception. This is how you can forcefully throw an exception. Whenever you throw an exception and you do not have a local try block to handle the exception, remember in the previous pages, you have to write the statement throws followed by the exception type that you are raising. Now, since there is no local try-catch block, that's why you are writing this instruction, then what's the point of this instruction on which I'm moving my mouse right now? The purpose of this instruction is that this is how you can force to throw an error. In the prior examples, we were never forcing an error. We were assuming if the user enters so-and-so stuff, the error will automatically be raised. Here we are throwing an error, and when we throw an error, we can choose what kind of error we are throwing. So we are throwing in a high balance exception error. Now, who will catch this and who will process this? That's the next picture, figure 1239. In the main method, we have a couple of input dialog boxes in which we are accepting the input from the user, in which we will accept the account number and the balance due from the user. And then we will call the constructor of customer account class, and we will pass the number and the balance. If the balance exceeds high credit limit, if the balance is a value over 20,000 or even equals to 20,000, in that case, over 20,000, then in that case, it will automatically go to catch in the main method. And the main method will then, because it is now in the catch will then display a dialog box on the screen in which it will say customer number so-and-so has a balance of so-and-so, which is higher than the credit limit. You could also do this in the same method is you can call HBE, which is the object of high balance exception type, and you can say HBE.getMessage. When you do that, you will get this error message. Customer balance is high. If you want to show that error message, you could also do that right here inside the catch. If there is an error, if there is no error, then JOption pane will simply display the customer number and the balance amount. So here is an execution of the program with an exception because the amount is over 20,000. So if the user enters a value over 20,000, then the catch will be called and the exception will be raised. Okay. So again, when I will let you guys code. There are 3 separate programs that you will code here. This is your high balance exception class. You have your customer account class, and then you have a demo class where you are using the customer account and passing values into it. In case there are any errors, then the exception will be raised and you'll be able to see the output. So again, let me know when you guys are done with these 3 figures: 1237, 1238, 1239. Okay, so in the last example in this chapter, which is on page 623, the author is showing us that how you can invoke some of the executable files on the Windows platform right from your Java code. For example, if you click on the Find button on the Windows and you type OSK, which is the on-screen keyboard application, you click on it and the on-screen keyboard will show up on your screen. You can run that executable file right from the Java code as well. And this is how the author is showing you can do that, is you can use your input object, scanner object here, this is what he's declaring here for a later on input, but that's not needed to invoke the executable file. What's needed to invoke the executable file is a process object, which is a Java built-in class. So the process object will then tap into another built-in class called runtime.getRuntime.execute method. In the execute method, in the double quotes, you will type command, which is cmd, it's a DOS command, /c, which is a parameter, and followed by the path where this is located. So what this will do is it will locate the keyboard, will run it, and will bring it on the screen. If anything goes wrong in the process, it will go to the cache and will display the error message. If everything goes as directed, then it will accept the input from the user using the scanner object to display to the screen whatever you input. So this is just the output that you will see on the screen as a result of running the program, and then you'll be able to input whatever you want to input. So go ahead and work with this example, figure 1248. For those of you who are done with the previous one, move on to figure 1248. Okay, I see some of you are still working on it. Christian and Cole and Robert Reed. Are you guys still coding or are you having any issues? Okay, Robert Reed is done. Okay, Christian and Cole.
Yeah, it's just taking me a while to write this stuff down. So
Oh, okay. How about you, Cole? Any Mac users here? Okay. Yeah, I don't know. This probably won't work on a Mac. Because
It's really cool that we can write things to open applications like this. I
right.
always knew we could do it, but I never ventured out to figure it out on my own.
And if you check the you do it activity also, right after this example, the you do it activity is about opening the calculator, which is using the executable file calc calc. Similarly, you could open Notepad or other executable files that are available, provided you give the correct path.
Okay, cool. I know Alan told us last class he wrote a program to change a colleague's desktop background every time he loaded in, and it would change it back every 5 minutes if he changed it. That's the kind of stuff I want to learn.
And, you know, I mean, .NET can work with the Windows DLL files. Java runs in a sandbox, so it can't mess up with operating system.
Okay.
Yeah, so that's one of the security features of Java, is that it doesn't let it go outside the sandbox in which it is running and access the resources of the operating system and mess with them. Java won't allow it to do that. But Windows applications like C#, for example, you know, it just runs natively in the .NET framework, which runs on top of the operating system, have far better access into the operating system, which could be dangerous to some extent than Java. And even more dangerous is C and C++, because C and C++ allow you to tap into the memory of your processor.
Ooh, that's scary.
Yeah, especially, I mean, like they can just peek into the processor's registers and store variables there, grab information from there. C was actually designed for that purpose back in 1970s, early 1970s. C programming language was designed to write operating systems. So that's why it can do a lot more than any of the other languages like C++ or C#. I wouldn't say C++, I would say C#. C++.NET cannot do what original C++ could do, because now C++.NET is running on the .NET framework, where the original C was running native. So that's why for a lot of the operating system programming, we would use C, C++. C++ gained popularity because C++ is object-oriented. So you could actually design objects, because a lot of the operating systems are object-based operating systems. So you can just use a lot of the stuff from the C and write it in C++. very, very close, except for some basic differences between the two languages. C is procedure oriented and C++ is object oriented. I don't know if any one of you are taking C++ in fall with Alan, but yeah, that's one of your, you can actually, that could count towards your elective.
So what's your take on, I was actually planning on doing Python.
That's a good choice also, because Python is among the top 5 leading languages. Since it's not part of our program, it's not a bad idea to learn Python. And I think there are 2 sections of Python in fall. One is in person and one is online. And I think I was talking to one of you about it last week. So yeah, that's another choice on the table. Like some people go in game programming route because they want to get a game programming certificate. Some people take C++, some people take other courses like you're thinking about Python. So, you know, with that 3 credit, you have a lot of choices here and there that you can go into. It used to be 6 credits of electives that we used to put in our program, but then state mandated all programs to reduce their number of credits. So we had to like reduce our program by 7 credits. So that's why we reduced the suggested electives down to 3 credits versus 6.
It would be nice if we weren't forced to take things like psychology and stuff, where we could take another programming elective. Like, I see the merit in it, but I would much rather take another programming class than intro to psych.
Well, that's state directed stuff. You know, state wants certain gen ed courses to be taught in the program, and they allocate X number of credits towards the gen ed. And then, yeah, it's all state controlled.
Gotcha.
Ugh.
Big brother controlling us.
And then when you go to the 4-year schools, they actually are also looking for, see if you, I'm like, I don't know if anyone of you already has an undergrad, because some people come to our degree program and they have an undergrad in a different major, or sometimes they have an undergrad in IT, in computer science, but they haven't learned the hands-on skills. So they come to Gateway to learn about the hands-on skills. But you will notice that only 1/3 of your undergrad degree is your major. Yeah, it's like, you know,
Which doesn't make sense.
it's that's how it is. Yeah. Then you have, if your school allows you to have a major and a minor, then between the major and the minor, you could say maybe like 50% of your degree is your major minor, and then the rest of the 50% is anything else. That's part of your curriculum sheet.
Bureaucracy.
So there are a lot of English classes, there are a lot of math classes, especially if you are doing computer science. There's also an option of doing computer science with arts, right? So in that, you don't take math classes, you have a choice of taking art classes or classes in the arts department, which doesn't mean art, it means liberal arts, by the way, right? So you can take liberal arts classes as opposed to taking as many math classes as BS, computer science BS versus computer science BA. There's a difference. Some schools do that. Yeah.
Lame. So you mean we're not going to be making NFTs in art class?
You know, when I went for my undergrad, I minored in mathematics, majored in computer science, and I took a lot of classes in School of Business. So my idea was that, you know, at some point in time, I will do my MBA. So after completing my master's in computer science, then I went for my master's in business administration. I mean, like none of those courses that I did at the undergrad level really counted towards any of the courses in the master's program. But it does help in the acceptance into the program. And then I had some extra credits in my program when I was doing my undergrad, so I could just take some classes in different departments. I could take classes of my choice. So I took classes in philosophy, I took classes in world religion, I took class in theater. I mean, like I took so many fun classes. It was nice to go into other departments and take classes and get to see students that you don't necessarily see in your department. So yeah, it was fun. Like I took class in public speaking. Yeah, yeah, there's so many classes that I took. I don't even remember them now, but it was fun. I think undergrad was far more fun than my grad school, because in grad school, all you're doing is you're taking your major classes. You get to see only your major people. I mean, like everybody's thinking the same way. It's like, okay, they're all a bunch of IT people interacting with each other. And I hated this one kid in my class. It wasn't a kid, it was an adult. I was taking this grad level course in my undergrad program because they ran out of classes for me in the undergrad program, because I took a lot of the classes in the undergrad program in my sophomore and freshman year. So they had to give me grad level classes in my junior and senior year. So I was sitting in this classroom, this gentleman, he was probably in his 50s. Anytime the instructor would be done with a problem explaining, and he will be like, you know what? That could be a good homework assignment if you could convert this algorithm into a C code. And he would literally ask for more assignments. Then we already had so much to do. He hated him for that. It's like, why? Yes, he would actually ask for more homework, literally.
You know, Saad, could we get an extra assignment at the end of today?
Don't
Gosh, I
start.
swear. The outrage.
I'm okay with that if your classmates are okay.
Doesn't sound like it. I think the work's ready.
Okay. Okay, guys, let's take a break here till 7:50. When we come back at 7:50, we'll start with chapter number 13, which is about file handling. So we'll be looking at some of the stuff that is in the book. We'll also be going outside of the book, because file handling is done in two different ways in Java. There's an old approach, which is called Java IO, and then there's a newer approach, which is called Java NIO. So your book emphasizes mostly an NIO approach, but I also want to introduce IO approach and then also go into the NIO approach. So whatever chapter 13 we could cover, we'll cover tonight. Whatever's left over, we'll continue with that next week. So I'll see you guys at 7:50. Binary files or those kind of files. So you are all familiar with how the files are structured in a particular typical computer, that you have drive, and drive has folders, and folders can have subfolders, and eventually you will get to the file. So when you're reading a file, you use slashes in the delimiter, in the path, as a delimiter between different items. However, the problem is in Java, the backslash is also used in escape sequence. Remember, you have like \n for escape sequence. So that's why the Java developers, if they're using the backslashes, they would use two of them. The two backslashes is escape sequence, which is telling the compiler that only pick one of the backslash. If you only put one backslash, it pretty much means that it's an error, because the compiler is expecting a escape sequence character after the backslash. So it just errors out saying something is missing. So that's why we use two backslashes as opposed to a single backslash. The whole idea of a file is that either you open it for read purpose, you open it for write purpose, you open it for append purpose, you open it for after reading, you want to search through the file. So the whole idea is that you want to, first of all, make sure that the file exists. If the file exists, you want to go ahead and open it. You want to go ahead and write to it or read from it. And then eventually you want to close it. Or if you want to delete, you can delete the file. So as I told you that there are two separate packages available to you in Java. One is called the Java IO package. The other one is called the Java NIO package. I'm stopping here as far as your book is concerned, and I'm switching over to the Blackboard. In the Blackboard, if you click under this week's button and scroll down just a bit, I've given you some notes on Java NIO versus Java IO. So I want you to read through these notes. They're not too many, it's just like this one area, okay? I want you to read this so that you understand the difference between IO versus NIO. And remember, buffered versus streaming. Streaming means continuous flow. Buffered means you bring some data, you display that while you buffer more. So that's buffering versus streaming. On the internet, you have a combination of the two. That as you're streaming, you're also buffering. And why do you do that? Because the content is so large. For example, if you're watching a Netflix video, the content is so much that it cannot wait for the entire video to be buffered to show you. So what it does as the data comes in, if it has enough data buffered to stream, it starts streaming. And then while it's streaming, it starts buffering more. That's why if you are towards the end of the movie and you go all the way to the beginning of the movie, it starts rebuffering. Anyway, go ahead and read this and then let me know with a green check that you're done reading this. And also when you're done reading, you can also go to this link right below, IO versus NIO. And you don't have to read the entire article, but just so that, you know, I mean, like you can read the first two topics, stream oriented versus buffer oriented and blocking versus non-blocking. It's basically, you know, the same stuff that I got over here.
Did you want us to write this out as well?
No, 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 just do your reading. Yeah.
Okay.
So to explain one point over here, it talks about blocking versus non-blocking. So Java IO, so various streams are blocking. That means that when a thread invokes a read or write, that thread is blocked until there is some data to read or data is fully written. So basically, when in a multi-threaded applications, which you will learn about in advanced Java, multiple processes are looking at the same resource. So Java IO package will block access to all processes when one process is using a resource. Whereas Java NIO is a non-blocking, has a non-blocking mode, which can enable a thread to request reading data from a content and only get what is currently available or nothing at all if no data is currently available, rather than remain blocked until data becomes available for reading. So the thread can go and with something else. So it basically allows for multi-threaded applications. Java NIO is a better choice than a Java IO. Now, what I did, let me clear your feedbacks here. Okay, I created a new class called demo file one. Now you can create the class called demo file one. We will first work with the examples with Java IO package. Then we will work with examples with Java NIO package. And you can also see the difference between the two as to what classes are used by the IO package and what classes are used by the NIO package. They don't use the exact same classes to do the exact same job, just so that you know. Okay, so let me create a try catch block. In the catch block, I want to catch an IO exception because these exceptions are of input-output type. I'm creating a file object. IO exception has a red line, even though we are done importing the package, because there is no line in the try that has yet been written that will invoke that exception. That's why it's complaining that this is unreachable right now. On line number 9, I've created a file class object called file1, which will tap into a file called names.txt. Do we have a text file names.txt already created?
No.
No. Okay, so we can write an if condition that if file1 dot create new file. So I can hover over and it says it automatically creates a new empty file named by this abstract path name if and only if a file with this name does not yet exist. So it will check to see if that file does not exist or it exists. If it doesn't, then it will create one for me. So I can now display an output, success, file created. Okay. And then otherwise, file already exists. So if I run this program the very first time, it will tell me success, file created, because the file doesn't exist. So it creates one for me. But if I run it again, it'll say file already exists because now it exists. Simple as that. Now you will be wondering, well, where in the world is this file? I don't see it. All you need to do is right click on your project and refresh. And here you can see names.txt. You know, you guys remind me of my college days when we learned JavaScript. And JavaScript has a dialog box that can pop up on in a browser. And back in those days, the browsers were not smart enough to kill an infinite loop in a JavaScript. We would create this HTML file with an embedded JavaScript, and we would send it to a friend in the same lab. You know, we were in a computer lab in the university as an email attachment to open the file. And as soon as the person would click to open the file, it would open up in a web browser and it'll be an infinite loop. They will close the dialog box. It will show the dialog box again. And we knew this person doesn't know Alt Control Delete because you could easily kill an application with Alt Control Delete. So they would just freak out. I know we're mean.
Sounds like fun.
Must use our powers for good, not evil.
How many of you have seen a CRT monitor?
I played Duck Hunt on one.
So in the good old CRT monitors, I don't know if you guys remember, there used to be some rollers at the bottom that you could roll for brightness and contrast.
I remember those, yeah.
Yeah. So that's another thing that I did to some of my friends. I knew that they would freak out. I turn it all the way to dark.
Yeah, those.
So they would come back from the break and they'll be like, oh my God, I was working on my project. The computer shut down. I didn't save a file. It was like, yeah.
Evil.
I bet you they never forgot to save a file before they walked away again.
Yeah, I would just, you know, yeah, I'll just fix it for them and they'll be like, you're mean. And remember,
What's fun?
you know, being 18-year-old, you do these kind of crazy things.
What's fun is there's a shortcut to go ahead and flip the display, and you just flip it upside down at work and then leave it.
Yep. All sorts of crazy stuff. Okay, so this will create the file. Now let's save this one as a demo file 2.java. Rename it. And now let's create, oops, 2 objects, file 1, file 2. The second one I would like to call new names. names.txt. File 1 is names, file 2 is new names. Now we would like to rename file 1 dot, oops, rename to file 2. Rename success. And let's say rename failed. And get rid of IO mess exception to just exception, because renaming doesn't really need an IO exception. So this time when you run this, it will say rename success, right? So you refresh your project and you will see that the names.txt has been changed to new names.txt.
And how did you get the file to show up again?
Just
On the left?
right click on the project and hit refresh. Got it?
That's not showing up.
Did you run the program?
Yes. And I ran the first one as well.
And your file is not even showing up?
Let me close the clips real quick and reopen it. Because it ran it and then I did it again, so it could not be created because it was already created.
So it looks like it is created.
It's loading back up. There it is.
Okay, cool.
Okay. That's weird.
Eclipse sometimes goes in solar or lunar eclipse mode, so you gotta just restart it. Okay, is everybody done? Because our next step would be to delete the file. So let's see, Aiden, Christian, Francisco, Greg, Jack, Oscar, and William. Christian, Jack, and William, any errors or you're just coding?
Just coding. Was there a demo file one? It must have cut out.
Yes, there was a demo file 1. You need
Okay.
demo file 1 to do demo file 2. Are you done with the demo file 2 code? Only then I'll show you the demo file 1 code.
I have a screenshot of it, so I can.
Oh, okay. So make sure you complete that, run that, because that will create the file that you're renaming in demo file 2.
Oh, I have a screenshot of demo file 1, demo file 2, not 1.
Oh, okay. So demo file 1 is basically this, where you create a new file called names.txt, which you rename in demo file 2. So you have to have a file created before you can rename it, right? So
Okay.
that's why you have to first code demo file 1, run it, right click on the project and refresh to make sure that the file is created, then code demo file 2, run that, and then refresh the project again to make sure the file has been renamed.
Got it. Okay.
So now let's save the demo file 2 as demo file 3. When you have the demo file 3, what we'll do in demo file 3 is we'll delete the file. So what is the name of the file? The file name is now new names, right? So let's change file 1 to be called new names.txt, and we will say file 1 dot delete. File deleted successfully, and file deletion failed. So after making this change, when you run it, it will say file deleted successfully. You refresh the project, the file should disappear. If you try to run this again, it will say file deletion failed because the file doesn't exist. What happened, Jordan? Any errors?
No, I was just making a joke about deleting the system32 folder on your computer.
Oh, yeah. No. And I gotta remember, Java runs in a sandbox.
So try it in C#.
I wouldn't until you hate yourself.
I'll let you do it first.
What's the worst that can happen?
Yeah.
Yeah, right.
More storage space.
Blank screen of death. Okay. Can you guys give me a check when you guys are done with this so that, I get all green checks? We'll move on to our next example, where we will create a text file and then we will read that text file. We haven't done that. So far we've just created a text file, renamed a text file, deleted a text file. Christian, how much are you caught up?
Not very.
I need a little bit more explicit answer than not very.
Oh, I have, I'm actually working on demo files 1.
Okay. Because after you complete demo file 1, the rest of the other 2 is just a 2-minute change.
Okay. And I'm almost finished with 1 then.
Okay, make sure you run 1 and make sure the file gets created. And in the chat, I'm just sharing with you guys the direct link to the file class on the Java doc, which is Java documentation. And that's where, if you scroll down, you will see that Java file class, which is part of the java.io package, is a child of the object class, direct child of the object class. And you can see that it has been around from JDK 1.0. That means from last almost a little over 25 years, this class has been around. And if you scroll down further, you can see that it has four constructors. Which one of these four constructors did we use, guys?
The second one.
The second one, very good. And in the list of the methods, I want you to identify the methods that we have used with the file object in the three examples, and click on it, and it'll take you down to the description and read about each one of the three methods we use, like we use delete, right? And then if you go to demo file 1, we used create new file. And if you go to demo file 2, we use rename to. So read about each one of the three methods.
So I ran it and it said success file created.
Okay, then create the demo file 2.
Okay.
And yeah, I mean, like what you do is you save demo file 1 as demo file 2, and then make the necessary changes. That will help you, lessen your coding time.
So I have an error in demo files too. IO exception is
Right,
underlined.
right. So get rid of IO is just the exception.
Okay. Okay. All right, rename success. And then the next one.
Is the demo file 3.
All right, it says file deleted successfully.
Okay, cool. Just refresh the project to make sure that the file is gone.
Okay. How do I refresh the project again?
Just right click on the project and hit the refresh button.
Okay. Yep.
Gone? Okay.
Yeah.
Okay. So guys, now let me clear your feedbacks. And what I would ask you to do is right click on the project. Do not right click on the SRC folder. Just directly right click on the project. Okay. So when you right click on the project, then click new. And then choose file. Right click on the project, new file. It will ask you that you want to directly create it on the project. Let's give this file a name, demo.txt. Demo, D-E-M-O .txt, and hit finish. We will type 4 lines of text here. You can also, whatever you want. I'm just typing some simple sentences. And save the changes. Whenever you're done typing 4 lines of code, as well as like 4 lines of text, save the changes, close demo.txt. Okay. Let me create a new class called demo file 4 with a public static void main. You know what? I misspelled the word here. I want to show you that I will go back and fix that spelling. And then we will rerun so that you can see that when you make changes to the text file and save the changes in the next run, it will reflect the change. So. If you don't have the exact same text, then you make some changes to your text. Once you run it once, reopen the demo.txt, make necessary changes, save it, and rerun the program. So I made the changes, saved, reran, it's fixed.
So for the file reader, is that an import?
Yes, all of these are imports.
Okay.
Yeah, just make sure that you organize your imports.
Okay, got it. Thank you.
So make sure those of you who are giving me a green check has also tested this, that you make changes to your text file, save it, and then run it again so that you can see that whatever changes you made is reflected. Okay. Now that everybody is done with this, we will add a variable, integer I equals to 1. A very, very minor change just to display the line number along with each line that I'm reading. So I wrote 4 lines, I got back 4 lines. Okay. Now let's save this example as demo file 5. In demo file 5, you will first of all scroll back up and rename the file name to demo file 5. Once that's done, you will now come down to line number 16 and 17. What I will do is I will merge line 16 and 17 into one line. Generally speaking, in Java, if an object is not needed for more than one line, for example, I created line 16. Line 16, I created an object called FR, which is simply tapping into file 1. That's all it's doing, right? I don't need it more than that line. So right here on line number 18, where I wrote FR, I could replace that with the right-hand side of the equation and then simply comment out line number 16. The program works exactly the same way. But Java developers would do that to avoid having to declare too many objects. If an object is needed in only one line, why create it and hold the memory? Similarly, line number 18, instead of file 1, if I just simply copy and paste the right-hand side of line number 10, I can then comment out line number 10 as well, and just simply rerun the code and work exactly the same way. However, if you do not know, if I would have directly written line 18, for some of you, it might be a bit confusing. That's why I did it in 2 separate files, and I made you save it as, so that you have both versions of the program, the shorter version, which is more condensed. So what happens on line 18 is it first create a file, temporary file object, and give the temporary file object to a temporary file reader object, and then gives the temporary file reader object to a permanent buffered reader object, which holds the contents of the file. Make sense?
Yeah.
Okay. So next I will create demo file 6 with a public static void main. Just copying some code. I think it wouldn't hurt to copy paste some code.
I didn't get that last line that you had edited in
Number 5,
yeah.
line number 18. Okay.
I didn't. Okay, so what's the difference between number? Oh, hold on. Yeah, number 5 and number 4.
Number 5 and number 4 is in number 4, we created separate objects for each activity. So what we did is we first created the file object to just grab the file. Then we gave that to the file reader to open the file reader. Then we assigned the file reader to the buffered reader. So the file object, the file reader object are not needed for other than more than one line. So there is no point of creating an object and holding the memory. So what demo file 5 did, it created a temporary file object inside the constructor of file reader and created the temporary file reader object inside the constructor of the buffered reader object. So you are doing everything in one line and getting rid of named objects and creating unnamed objects on the fly.
Okay. So it's just making it like
More
More
condensed,
Yeah.
condensed, less code, and more memory efficient.
all right, I've got it now.
Okay. Now demo file 6. I copy pasted some of the code from demo file 4. I'll create demo file 1 and demo file 2. And demo file 2 will tap into a file called demo2.txt. Okay, so the idea is to read data from one file and write it to the other file. So buffered reader n equals to new buffered reader, new file reader, file 1. Then we have a buffer writer. So just like you have buffered reader, you have a buffered writer. Now, the code that I copy pasted is very similar to the code that you had in demo file 4. I just got rid of the piece where it said line number this. So I got the declaration of the integer out, increment, and all of that stuff I took out. So I am reading, I'm reading from the same file, which is demo, and I'm putting it in the string, and I'm throwing the string out on the screen. Now, instead of throwing it out on the screen, I want to throw it into a file. So instead of writing system.out.println, I will say out.write. So read the data line by line and store it in the demo 2. So it's just reading it and writing it, reading it and writing it. After you are done reading and writing, then close the file objects. So simply in dot close and out dot close. Okay, so save the changes, run the program. It will display you a message in the console, then refresh your project. That's what it is asking you to do. And you should see demo2.txt, which will have the exact same code as demo1.txt. Not on 4 lines. I will make the modification next to show you how you can put it on 4 different lines. But for now, it's all on 1 line. So when you guys are done with this example and have made sure that the demo2.txt is created, open it to make sure that it has everything on the same line. And then give me a green check.
Mine put it all on the same line.
Yeah, that's what it is supposed to do.
Okay, my bad.
Yeah, yeah. That's why I asked. It should put all 4 on the same line.
Gotcha. Sorry.
Does anybody have any questions about this code? Did you all understand this?
So far, so good.
Okay, I'm trying to go with simpler code so that you guys get the concept rather than giving you something a lot complicated that you would struggle to follow. That's why the examples are shorter. In case if anybody is wondering, why are you not giving us a lot of code?
This is nice. Easier to understand in shorter bits.
Okay. Oh, Christian, are you done? I noticed you didn't give a green check.
I just figured out an error that I had.
Okay.
So I am almost done. I'm at in.close right now.
Okay, cool. So the most important line is line 22, that instead of throwing an output to the screen through system.out.println, remember, system class doesn't own out. Out is an object of print writer class. So print writer class allows, it has a built-in non-static function called write, which allows you to write stuff to the screen. Instead of using the print writer's write method, we are using buffered writer's write method. And through that, we are writing from the buffer to the buffer, from the read buffer to the write buffer. The read buffer is with file 1, the write buffer is with the file 2, which is demo 2, I mean. So Christian, make sure you run it. After you run it, you will see the output that I see at the bottom. You will refresh your project and you will make sure that you have demo2.txt. And then give me a green check.
Sorry, what was that again?
Once you are done coding, run your program. You will get one line of output that I'm also seeing on my screen. And then you refresh your project and make sure you have demo2.txt listed as one of the text files. Double click to open it to make sure that it has all lines written on the same line.
Okay. Oh, there it is. Okay, I was getting an error and I didn't know where it was, but I just had an extra closing parenthesis.
Okay.
So read write operation done. Refresh your project. Okay. Done.
Get it? Demo2.txt?
Demo 2. Yep.
Okay. Did you double click to open it to see that it has text, everything written on the same line?
It is all on line 1. Yeah.
Yep. Cool. Awesome. You can now come back to demo file 6.java and let's save demo file 6.java as demo file 7.java. And now in the demo file 7.java, I want you to change the name of the file from demo2 to demo3.txt. That's the first change you will make. After you, of course, we need to rename the file to demo file 7. Change the demo2 to demo3. Scroll down to line number 22. On line number 22, as we write the line, we will concatenate it with the new line character /n. And I'm making some other changes, like on line 27, I'll just say, refresh your project to see the demo 3. Anyway, run your program after these minor changes. Once you run your program, you should see the output, refresh your project to see demo 3. And now refresh your project. And you should now see demo 3. If you open it, demo 3 will have everything on a new line.
So why do we need to refresh the project first?
Because the file is created, it just doesn't show until you refresh.
Ah, okay. And then in demo 3 text, or .txt, there's supposed to be 5 lines, right? One that's empty.
Yeah.
Okay. Got it. Just wanted to be sure.
Okay. Can you guys give me a green check when you're done? So we have Jack Lear and Jonathan. Jonathan, are you still coding the demo file 7? Oh, you're done. Okay, cool. Okay, now let's save demo file 7 as demo file 8. Rename the file to demo file 8. And on line number 13, change it to demo4.txt. Scanner object, you guys remember? Scanner object, okay. Now scanner object, typically you guys create as system.in. Now, go ahead and write that line first, line 15. So make changes to line 14 and write line 15. When you type system.in, what exactly do you mean by that? When we write system.in, what do we mean by that?
It's what is being input by the user.
It means you will take your input from the system input device. That's why it takes the input from keyboard. However, if you want the scanner object to take its input from a file, you'll write the name of the file object. You could redirect it to take its inputs. It could you could redirect it to change its input source. Okay, is everybody following that? Now I can write a while loop. In fact, let me do this. Integer count equals to 0. Okay, while scanner object dot has next line. Okay, as long as the scanner object has more lines to read. Okay, so sc dot input dot next line. Okay. You're just reading the line. Okay. What's the whole point of this code? The whole point of this code is I'm counting the number of lines. That's all I'm doing. Okay, so read next line, but don't store it. But don't store it anywhere. Increment count on each read. I'm just waiting for everybody to complete this much. Because what I wanted you to do next is I want you to select all the remaining code, lines 23 through 35, and comment it. How do you comment the code? You simply go to the source menu and you can just add a block comment like that. Okay. Or hold on a second, and don't add the block comment. Let's do the toggle comment. Toggle comment is fine. Do a toggle comment. It's very important that we all work together on all the steps. So I see that Aiden, Cole, Jack, Oscar. Okay. I think everybody is done but Aiden. It doesn't seem to want to comment out. I mean, like, okay. Can you at least select all that code and at least cut it so that it's not there anymore? And then you can paste it back again. Is it letting you cut the code out? Oh, might need to restart Eclipse. Okay, close Eclipse and open it again. Let me know when you're ready. And for the rest of you, go ahead and run the program. It should just display you total number of lines are 4. It's important to comment the code down below because I don't want to do any read write operations right now. I just wanted you to see that it can read that there are the total number of lines of 4. There are 4 lines. And this kind of a read is called sequential read because we're going line by line. Is it working, Aiden, now? Okay. Okay. Now, did you run, Aiden, to make sure that it shows the total number of lines 4? Okay. Okay, cool. Now what I would like you guys to do is uncomment the code that you commented before. So you can select all this code and then you can toggle comment to uncomment it and comment the line that we displayed that showed the total number of lines are 4. So comment out that line. So we have 2 files, demo and demo 4, that we are using in and out on the buffer reader. The rest of the code is same except for line number 30. Line number 30 is where I'm going to be making the change. Sorry. Now, did you guys understand what I did on line 31?
Kinda.
Kind of,
Kinda.
kind of.
Not fully.
Not fully, okay. If you guys remember, we learned about a control operator which can replace an if condition. So I declared a variable I equals to 1, and I'm making sure that if I is less than count, I want to write the string that I've read along with a new line character. And if I have reached the count, that means I'm reading the last line. The last line I want to write as it is without a new line character. So remember in the demo 3, we had a blank line. I
Mhm.
don't want to have a blank line after the last line. So in the demo 4, I don't have a blank line. So I just made sure that if it is the last line I'm writing, then don't write a /n with it. So it makes a choice based on if I is less than count, then it will write this. If I is equals to count, it'll write that.
Okay.
Okay, it's yeah, it's a shorter version of if else. So again, when you guys are done with it, make sure that you make, I made some changes to line 37 to change it to demo4.txt. Again, you run it and you refresh the project, and then you open demo4.txt to make sure that it is fine. Okay, everybody got this now? Give me a green check whenever you guys are done. Yeah, whoever is done.
So I'm having an issue. So I run the program and then demo 3 still has
We're not looking at demo 3, we're looking at demo 4. You got to refresh the project to see demo 4.
okay.
Got it?
I'm refreshing, but I don't see a demo 4.
Okay, can you scroll up to the top to make sure that you have demo and demo4.txt? Okay, and also make sure that you wrote line 31 correctly.
I missed line 32 actually.
Okay. So after that, you run the program. And then you refresh the project and open the demo 4. The demo 4 should not have an extra line.
Yep.
So guys, we were just at the beginning of chapter number 13. You know, we still need to work with chapter 13. We only worked with the java.io package. We still need to work with java.nio package. We did look into some of the classes like buffered reader and the file reader. But then there are also a lot of classes other than these 2-3 classes. So we did look into some of these classes that are talked about on pages 651, 652, but we will continue to work with chapter 13. So the assignment for this week is based on chapter number 12. And also you have a quiz on chapter number 12. So I have given you one problem to solve from the book, from chapter 12, from the programming exercises. That is question number 5. And then you have a quiz to complete on chapter 12. So we will look at chapter 13, and most probably we will try to go into chapter 14 as well next week, which is about the graphical user interface programming in Java. And that will be our main focus till the end of the program, until the end of the course. Chapter 14 will be our main chapter. So we will start with chapter 14 on the 5th. And that's what we'll be working on the 5th and the 12th on chapter number 14.
Sounds good.
Okay, so that's all for tonight. And I'll see you guys tomorrow afternoon for the control language, and probably for some of you next week.
Have a good week.
You too.
Yep.
Thank
Have a
you.
good night.
You too. Good night.
Have a good week.
See you next week.
Good night.
Have
Thank
a
you.
good one. Have a
Bye.
good one.